Aluminum foil has two distinct sides, one shiny, one matte. Ever wondered if the orientation matters? Is one side better for cooking, or is it just a manufacturing quirk? Today, we'll unwrap the mystery behind these two sides. We'll explore aluminum foil's journey from laboratory curiosity to kitchen staple, and discover why it's indispensable. Does it matter which side faces out? Let's settle the debate once and for all. Before the 20th century, tin foil was used for food. Its drawback, a metallic taste. Surprisingly, it wasn't tin, but led a serious health risk. Aluminum's story is extraordinary. In the 1850s, it was more precious than gold. Napoleon III served it to his most honored guests over gold, and the Washington Monument's aluminum cap cost more than the entire rest of the structure. The Hall-Héroult process, developed in 1886, made aluminum production economically viable. This transformed it from a precious metal into an industrial commodity, with prices plummeting. In 1910, commercial aluminum foil emerged, a revolution in food preservation. It quickly became popular, offering superior protection against moisture, light, and air, without any metallic taste. Aluminum foil, a versatile wonder material. Let's explore its diverse applications. Food storage is its most familiar use. Foil wraps and stores food, preserving freshness by creating an impermeable barrier to light, air, and moisture. Its reflective properties also protect nutrients. Aluminum's thermal properties make it an excellent insulator. As a radiant barrier, it reflects up to 97% of heat, keeping food warm or protecting spacecraft from extreme temperatures. In electronic warfare, aluminum foil played a key role. During World War II, the RAF used window, foil strips dropped from aircraft to confuse enemy radar. This chaff exploits aluminum's electrical conductivity and reflective properties. Modern military aircraft still use similar technology. Aluminum foil revolutionized food storage and preparation. Its versatility made it ubiquitous, from the kitchen to the International Space Station, an indispensable tool of modern civilization. Aluminum foil begins as a thick sheet, gradually rolled thinner and thinner under immense pressure. This intense process eventually makes the foil finer than a human hair, and also significantly strengthens the metal through work hardening. When the aluminum becomes too delicate to roll individually, manufacturers employ a clever and essential technique called double rolling. Two sheets are rolled together simultaneously. This ingenious method is precisely why foil has its distinctive shiny and matte sides. The sides of the aluminum that contact the highly polished steel rollers become shiny, gaining a smooth, mirror-like finish from the friction and pressure. In contrast, the inner sides, which are pressed against each other, remain dull. They develop a slightly rougher, matte texture from the direct aluminum to aluminum contact, without roller interaction. Once the desired thinness is achieved, the sheets are separated. The result is foil with one shiny side from the rollers and one dull side from internal contact. This isn't a deliberate design choice, but an inevitable outcome of the double rolling process and the fundamental physics of creating such incredibly thin metal sheets. So, does the shiny or dull side of aluminum foil affect cooking? This is a common kitchen myth we can definitively debunk. The truth is, for regular foil, it doesn't matter. Both sides conduct heat equally. The difference in heat reflection or emissivity between the shiny and dull sides is less than 5%. Practically, this means a temperature difference of less than 1 degree Celsius. Whether roasting or covering, both sides are functionally identical. Heat transfer in cooking relies on conduction and convection, not surface reflectivity, so the finish has virtually no impact. The only exception is non-stick foil. Some brands apply a non-stick coating, usually to the dull side. This creates a genuine functional difference, so use the coated side correctly to prevent sticking. For regular foil, however, use either side with complete confidence. Science confirms it makes no difference. Aluminum foil's uses extend far beyond the kitchen. It can sharpen dull scissors, clean rusty grills when crumpled, or even optimize Wi-Fi signals with a parabolic reflector. Its most awe-inspiring use is in space exploration. NASA uses aluminum foils for temperature regulation. The James Webb Space Telescope's sunshield, partly aluminum-coated, keeps instruments at -233 degrees Celsius, while its sun-facing side reaches 85 degrees Celsius. Its reflective properties deflect solar radiation, maintaining stable internal temperatures. Apollo lunar modules and Mars rovers used it for thermal protection in harsh conditions. In electronics, foil shields sensitive components from electromagnetic interference. It's found in everything from mobile phones to MRI machines. Artists and architects embrace its aesthetic properties. The Guggenheim Museum. Bilbao's cladding was inspired by its flowing, light-changing surfaces. Molecular gastronomy uses its thermal properties for precise cooking. Aluminum foil has an environmental footprint. Its production is energy-intensive, requiring significant power, and bauxite mining can disrupt habitats and degrade soil. However, aluminum is 100% recyclable without quality loss. Recycling saves up to 95% of the energy needed for new production, making it one of our most sustainable materials. To recycle foil, rinse off food residue, check local guidelines. Many facilities process it, but some require it clean and formed into a ball larger than a golf ball for proper sorting. The future of aluminum foil looks increasingly sustainable. New production methods use renewable energy and advanced recycling technologies recover aluminum from complex waste streams. In conclusion, the two sides of aluminum foil are simply a manufacturing byproduct, not a cooking secret. Its true marvel lies in its versatility, from culinary uses to space exploration and everyday life hacks. Every time you unwrap aluminum foil, you're handling a material embodying centuries of human ingenuity, from the chemistry of electrolysis and physics of heat transfer to the environmental science of sustainable recycling. While aluminum foil is incredibly useful, it does have an environmental impact. Producing aluminum requires significant energy, and mining bauxite can have ecological consequences. However, aluminum is 100% recyclable, and recycling it saves up to 95% of the energy needed to produce new aluminum. To make sure your used foil gets recycled, try rinsing off any food residue before tossing it in the recycling bin. As we look to the future, aluminum foil will continue to evolve alongside our changing world. Researchers are developing biodegradable coatings and new recycling methods to further reduce its environmental impact. Imagine a world where every piece of foil is reused, where innovation transforms even the simplest materials into solutions for global challenges. The story of aluminum foil is a reminder that progress is built on curiosity, science, and a commitment to sustainability. So next time you reach for a sheet of foil, remember, you're holding a piece of human ingenuity that connects the past, present, and future. And here are a few more surprising uses. Polish silverware, protect pie crusts from burning, create makeshift funnels, or even make a stylus for your touchscreen. The possibilities are endless. Aluminum foil is truly a marvel hiding in plain sight. The next time you use aluminum foil, appreciate the extraordinary science behind it. Wonder exists right here in our kitchens. Thanks for watching, and don't forget to like and subscribe for more stories about the fascinating history behind everyday things. Your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories of everyday things uncovered. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.